saya ucapkan thank you very much to the organizer, especially Prof dari Universiti Muhammadiyah. Am I correct? Ya, dan juga kepada penceramah-penceramah, to all speakers from Universiti Muhammadiyah dan juga dari UTHM sendiri. I was informed that the speaker from here is Associate Professor Dr. Chan. So I will take this opportunity. Before I forget, I would like to thank to Dr. Associate Professor Dr. Fadilah binti Ismail for inviting me and for giving me this opportunity. I think this is a golden opportunity for us between both parties to work together collaboratively and to work closely in delivering these what we call as guest lecturer between UTHM and also Universiti Muhammadiyah. So I think this is such a very interesting effort, and I think it's very important for us to continue, yeah, in sharing our knowledge and also experience. So I really hope that this session will be fruitful, and also the insights that are going to be shared by both speakers will be beneficial to all participants who are actually joining this session. And I would like also to thank and also to express our gratitude on behalf of our Faculty of Technology Management and Business. I would like to thank to the organizer for giving opportunity to our speakers from UTHM to share their experience, their expertise with the participants. So with that, I wish you all the best, and may Allah bless us, and may Allah ease everything for this session. Inshallah. Thank you very much.
Right. Thank you very much Bapak Dekan for
Sama-sama.
the speech. Keren banget. Very positive, very warm. Thank you. Baik, again kita akan melanjutkan. Silakan Ibu Dr. Irnawati untuk memberikan greets juga dan langsung mempersilahkan panitia untuk memutarkan video sebagai jawaban dari tanggapan Bapak Dekan dari UTHM. Silahkan Ibu.
Okay, Bismillah. Thank you, Mem Maharida. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. Good afternoon, ladies and gentlemen. It is my pleasure.
Good afternoon.
Thank you. Okay. Good afternoon. It is my pleasure to welcome you to today's international guest lecture, hosted by the postgraduate program of Universitas Muhammadiyah Makassar in collaboration with University Tun Hussein on Malaysia. I'm Dr. Inawati Idrus, and I'll be your moderator for this insightful session under the theme Learning Innovation on Education. Okay, to begin our program, we have here the opening speech from Deputy Dean, Professor Madya Dr. M.D. Asrul Nasib bin Masrom. He is Deputy Dean Research, Development and Publication in Faculty of Technology Management and Business, University Tun Hussein on Malaysia. And now let us hear the recorded message from Professor Dr. Irwan Akib, M.Pd. He is Director of a Postgraduate Program, Universitas Muhammadiyah Makassar. Please committee play the recording. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah wa syukrillah la
Waalaikumsalam warahmatullahi wabarakatuh.
Yang kita sama hormati, kita muliakan Profesor Madya Dr. Asrul Nasib bin Masrum, Deputi Dekan Fakultas Teknologi Manajemen dan Bisnis Universitas Tun Hussein on Malaysia. Yang kita sama hormati Ibu Dr. Chan Shiau, dosen Universitas Tun Hussein on Malaysia, yang insya Allah akan bertindak sebagai narasumber. Demikian juga kami hormati Ibu Dr. Sitti Fithriani Saleh M.Pd, di samping sebagai Ketua Prodi juga akan menjadi narasumber pada kesempatan ini. Terima kasih kepada Ibu Dr. Irmawati Idrus S.Pd yang bertindak sebagai moderator pada kuliah tamu kesempatan ini. Tentu saya atas nama pimpinan Pasca Sarjana menyampaikan penghargaan dan terima kasih kepada seluruh peserta yang telah bersedia untuk hadir bersama-sama kita dalam rangka menimba ilmu dan sekaligus tentu akan berbagi pengalaman dalam dua negara. Indonesia, Malaysia, dua negara serumpun, tentu punya kesamaan dalam banyak hal, walaupun juga tentu akan ada perbedaan-perbedaan. Perbedaan itu bukan hal yang harus dipertentangkan, tetapi justru harus menjadi rahmat bagi kita semua. Hadirnya kuliah tamu hari ini bukan sekedar untuk berbagi ilmu, berbagi pengetahuan, tetapi juga menjadi langkah awal bagi dua institusi, baik Pasca Sarjana Universitas Muhammadiyah Makassar maupun Fakultas Teknologi Manajemen dan Bisnis Universitas Hussein Malaysia dalam bertukar pengetahuan, bertukar ilmu, dan mungkin juga pada saatnya nanti kita bisa bertukar dosen dan mahasiswa sehingga pengalaman di dua institusi ini bisa saling memperkaya kita dalam pengembangan ilmu, pengembangan pengetahuan di masa yang akan datang. Kita berharap bahwa dengan hadirnya kuliah tamu ini akan semakin memperkuat hubungan Indonesia-Malaysia sebagai dua negara serumpun dalam pengembangan ilmu, pengetahuan, dan teknologi. Sekali lagi terima kasih untuk semuanya. Mari kita membuka kegiatan ini dengan sama-sama membaca basmalah. Bismillahirrahmanirrahim.
Bismillahirrahmanirrahim.
Nasrun minallah wa fathun qarib wa basyiril mu'minin. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Professor Irwan Akif. Okay, well, let's now move to our first guest lecture. Dr. Sitti Fithriani Saleh with a presentation entitled Integration Cultural Context and Technology in Mathematics Education. But before that, allow me to introduce our first speaker, Dr. Sitti Fithriani Saleh. She is a lecturer and mathematics education researcher at Universitas Muhammadiyah, Makassar, Indonesia. She earned her doctoral degree from Universitas Negeri Malang with a focus on mathematical connection and problem posing strategies among pre-service teachers. And her earlier studies in mathematics education were complete at Universitas Negeri Surabaya and Universitas Muhammadiyah Makassar. Dr. Sitti is passionate about integrating cultural context and digital tools into mathematics instruction. Her recent research include the development of culturally based ebooks for primary students in West Papua and studies on mathematical curiosity and self-regulated learning among students. And she is also actively involved in community service program, promoting numeracy awareness and anti-bullying education and sociopreneurship empowerment. Let us warmly welcome Dr. Sitti Fithriani Saleh to take your presentation. Dr. Sitti, time is yours.
Thank you very much, Dr. Irna. Allow me to share my slide. Okay. Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi
Waalaikumsalam warahmatullahi
Wabarakatuh.
wabarakatuh.
Warm greeting to everyone. It's my honor to extend my highest respect to the Professor Madia, Dr. Muhammad Asrul bin Nasib. Professor Madia Dr. Muhammad Asrul Nasib bin Masrum, Deputy Dean of Faculty Technology Management and Business University Tun Hussein on Malaysia, and Professor Dr. Irwan Akib, the Director of Postgraduate Program Unismu Makassar. And I also warm welcome to Dr. Chan Shiau as the speaker from University Tun Hussein on Malaysia. I look forward to learning from your session as well. And I would also like to express my appreciation to LBPKUI, Mem Maharida, and the team, and also Prof. Fadila binti Ismail, Professor Fadila binti Ismail from University Tun Hussein on Malaysia for kindly facilitating this international guest lecture. I would also like to warmly welcome to all lecturers, teachers, and students who are joining us today. I truly hope this session will provide meaningful insight and valuable knowledge for all of us. I would like to begin my presentation with its title, Integrating Cultural Context and Technology in Mathematics Education. Well, here is an outline of what I'll be sharing today. First, why cultural context matters, challenges in integrating culture into mathematics education, the role of technology in mathematics education, example, digital book for teaching mathematics in a cultural context, and final thought. First, let's take a look at the underlying reason why culture is important in mathematics education. Mathematics and culture are deeply intertwined. Mathematics is a product of culture. Diverse culture groups create unique mathematical reality through their ideas, approaches, methods, procedure, technique, and practice in daily life. Cultural activities, daily practices, and student personal experience serve as valuable resources for communicating complex and abstract mathematical concepts. Context is essential in mathematics learning as it connects mathematical ideas to student daily lives and support the development of conceptual understanding in mathematics problem solving. Utilizing the distinctive cultural aspect of students can encourage active participation in learning. Incorporating culture in learning also fosters student appreciation and love for their cultural heritage. So, integrating local culture context into mathematics learning can provide students with meaningful learning experiences. This initiative supports the Sustainable Development Goals, particularly SDG 4, quality education, and SDG 11, sustainable cities and communities. It's also support the Astacita 8 of Republic Indonesia, strengthen the alignment of harmonious living with the environment, nature, and culture, and promote interreligious tolerance to achieve a just and prosperous society. Next, we will look at some of the challenges in integrating culture into mathematics education, particularly in Indonesia. Indonesia will offer 17,000 island and more than 1,300 recognized ethnic groups possess a rich and diversity cultural heritage. Each region has its own unique cultural identity, expressed through traditional clothing, dances, music, architecture, craft, traditional food, local wisdom, and other cultural significant practices. This diversity presents both opportunities and challenges for integrating culture into educational setting, including in mathematics education. The challenges include but are not limited to lack of cultural-based teaching resources, limited knowledge of local culture, difficulty linking culture and mathematics. Teacher may struggle to identify appropriate cultural elements that align with their learning objectives, as this requires strong content knowledge and pedagogical skill to ensure meaningful integration. And the curriculum constraints is also challenging. Pressure to meet curriculum target often limit opportunities to design and deliver culturally rich lessons. Let me provide a small example to show how cultural context can present challenges, particularly when posing mathematics problem. I take this example from my research. One of the participants in my research proposed a problem like this. This is a simple problem. You can see this. Bumira owns land in Bogor with a length of 12 centimeter and width of 5 centimeter. What is the area of the land? Well, this word problem can be mathematically solved by multiplying 12 by 5, yeah. However, its contextual setting does not align with the realities of everyday life. Even 1 square of artificial turf is larger than the area described in this problem. What kind of land with an area of 60 centimeters square? And next, let me share another example from my other research. One of the pre-service elementary teacher posed this word problem. Aisha has 64 Toraja traditional customs and 48 tongkonan. This traditional custom and tongkonan will be distributed equally among her friends for a mass dance performance. How many Aisha's friends can receive both the Toraja traditional customs and the tongkonan? Well, this pre-service teacher aimed to pose a problem involving the greatest common factor, FPB, ya, faktor persekutuan terbesar. However, because the largest number and without having any leftover, which I add here in red text, missing from the problem statement, it become an open-ended. Jadi awalnya it's close problem with GCD, GCF, but it become an open-ended, allowing for various problems, various possible answers. From a real-world perspective, assigning equal number of both customs and tongkonan to friends may not practically sense. Tongkonan is a traditional Torajan house, which are worth hundreds of million, even up to billion rupiah. Aisha must be really rich to giving away tongkonan to her friends. 48 tongkonan. Even its miniature version, I add this miniature, but even miniature of tongkonan is not used in the dance. So this is practically not make practical sense, yeah. That's the example. And next, we've seen the challenges of integrating culture into teaching. While it can be difficult for teacher today to integrating the culture to mathematics education, but today's technology offers valuable support. Technology support various aspects of teaching and learning, such as collaboratively design syllabi and lesson plans. We can use Google Document or Google Sheet, or in Universitas Muhammadiyah Makassar, we have GiveLearn, our LMS, generating ideas in developing instructional material, we can use ChatGPT or like Perplexity or others. Creating interactive learning media, we can use Canva, Magic Slide, Book Creator, or others. Constructing assessment, we can use quizzes, Mentimeter, Kahoot, or others. By streamlining 10 tasks, technology enables teachers to allocate more time to instructional quality and student engagement. Next, I would like to present an example of how technology can be used to develop mathematics learning that incorporates local culture context. This example is taken from a study conducted by Muhyiddin, the student under supervision of Prof. Irwan Akib and myself. This research received a grant from the RTPM Kemendikbudristek Indonesia for the penelitian thesis magister scheme. He developed an e-book incorporating local cultural context for mathematics learning using Canva, ChatGPT, and Flip HTML5. This is the display of the e-book. However, the QR code here and the links are distorted. I distorted because the book is still in prototype stage and it continues to be developed. But you can see here, Muhyiddin integrated the local culture, Papuan, West Papuan culture to his ebook. Used here character Yosef, Sitti, and Ayu. Yosef from Papua, West Papua, Sitti from Sulawesi Selatan, and Ayu from Jawa Timur, is Java. Finally, we've reached the final task. Mathematics around us. Don't let our children grow up fearing or avoiding mathematics. Let's help them see the beauty of mathematics in their surrounding. Learn it through their own culture and take pride in their valuable cultural heritage. Thank you for your attention. I hope this presentation has inspired ideas and reflection. Wassalamualaikum warahmatullahi wabarakatuh. Dr. Irna, thank you very much.
Waalaikumsalam warahmatullahi wabarakatuh.
Okay, Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Dr. Siti Fithriani Saleh, for your insightful presentation. And the second speaker have been with us now.
Bentar dulu Ibu, izin.
Oke.
Insya Allah nanti untuk Dr. Chan akan bergabung di pukul 16.20. Atau kita tanya dulu Dr. Chan. Dr. Chan sudah di forum. Silakan Bu ditanya dulu.
Okay, hello Dr. Chan. Are you already with us?
Yes.
Okay, Dr. Chan. Do you want to
Bentar, izin.
start?
Izin Ibu,
your-
sebentar Ibu.
Yeah.
Sebentar,
Okay.
sebentar. Maaf saya menginterupsi. Izin Ibu. Ibu Dr. Fadilah, sebelum kita memproceed kepada Dr. Chan, the schedule that we got it will be 4:20. Is it okay if we start right now?
I think it's okay. I beg to Dr. Chan. If Dr. Chan is ready, then we can proceed.
Oke, Ibu Dr. Irnawati, kita persilahkan terlebih dahulu Profesor Fadilah untuk menyampaikan sesuatu sebelum kita persilahkan Dr. Chan, karena Ibu Dr. Fadilah dengan Dr. Chan ini satu tim. Satu tim di dalam presentasi ini. Silahkan Ibu Dr. Irna, dipersilahkan dulu Ibu Dr. Fadilah, baru ke Dr. Chan. Silahkan Ibu Irna.
Alright, okay. Alright, thank you so
Oke,
much.
silahkan langsung saja Ibu.
Alright, okay.
Dr.
Thank
Fadilah.
you
Oke,
so
silahkan.
much, Bu Rida. I think thanks to the moderator, Dr. Sri Saryani, if I'm not mistaken. I'm sorry if salah. So today, thank you very much. Assalamualaikum and warm greeting. I think it's an honor for UTHM, especially UTHM, to take part for this meaningful collaboration with Universitas Muhammadiyah Makassar. I think this is learning innovation on the knowledge and mathematics education. This is our term for, I think, this international what we call slot, I think, between UTHM and Universiti Muhammadiyah Makassar. So this is, I think, knowledge through cross-border academic engagement between two universities. It's a quite, I think, inspire collaborations between both parties. And I think let these platforms inspire new idea, and then strengthen our true university, which is both party, and I think force the impactful dialogue on how we can transform education for the better future. I'm sorry, I think I should thank you so much to Universiti Muhammadiyah Makassar, especially for the director of postgraduate program Universiti Muhammadiyah Makassar, to invite us these collaborations. And then thank you for the first speaker, guest speaker, which is Dr. Sitti. I think that is a good collaborations in terms of knowledge sharing. They have a lot of things that new terms that I learned from you. Inspire the new idea about, because we have a difference what we call expert method. So now I think they have opportunity to UTHM to share by Dr. Chan in the perspective of how I think the enhanced mathematics understanding through computer thinking approach in knowledge driven learning. I think that's all remark for me as a representative of UTHM, especially for the Faculty Technology of Management. So I pass back to moderator. Thank you very much.
Okay, thank you very much, Dr. Fadila. And now, okay. Okay, next, we will hear from our second speaker, Dr. Chan Shiau. And today, she will speak on the title in changing and mathematical understanding through computational thinking, innovative approach in knowledge driven learning. Okay. Then, before that, ladies and gentlemen, it is my honor to introduce our second speaker, Dr. Chan Shiau. She is a senior lecturer at the Faculty of Technology Management and Business, University Tun Hussein on Malaysia. And Dr. Chan holds her PhD in Mathematics Education from University Technology Malaysia, where he also completed his master and bachelor's degree. His academic journey is grounded in mathematical thinking, educational innovation, and operational management. He has an extensive research portfolio focused on computational thinking, knowledge-driven learning, business mathematics, and digital education transformation. As an active scholar, he has authored numerous international journal articles, many book chapters, and research projects, including collaborative studies on artificial intelligence in education and sustainable development. Okay. Dr. Chan is also a certified professional technologist under the Malaysia Board of Technologists and a lifetime member of several academic associations. Okay, then before that, we continue to lecture. Ladies and gentlemen, if you have a question during the presentation, please drop your question in the chat box. Well, with great pleasure, let us welcome Dr. Chan Shiau Wei. The screen is yours.
Thank you, the moderator. Can you hear my voice?
Okay, it's clear.
Good afternoon to everyone, and good afternoon also to Dean and the Deputy Dean, and also all the lecturers and the students. It's a truly an honor to be part of this online sharing section with all of you from the Universitas Muhammadiyah Makassar. I'm excited to share some thoughts on the topic that related to the computational thinking in the mathematics education. Before that, let me share the screen. Okay, today I will be discussing enhancing the mathematical understanding through the computational thinking, CT, the innovative approaches in the knowledge-driven learning. Okay, first of all, I would like to share how I started my research in the computational thinking within the mathematics classroom. From 2019 to 2020, I was working as a postdoctoral research fellow at the National Institute of Education, NIE, Nanyang Technological University, NTU, Singapore. At that time, I was involved in a research project titled Designing for Disciplinary Specific Computational Thinking, How to Bring the CT into the Mathematics Classroom. The project aimed to integrate the CT skills into the lower secondary mathematics education, and it highlights two concepts of the CT. The first one is the CT as a general problem-solving skill set involving the decomposition, pattern recognition, abstraction, and the algorithmic design. And the second concept is the CT as the development of the solutions executable by the computing agents, which requires the deeper curriculum pedagogical changes. And the study found that incorporating the CTs through the worksheets, the modeling tasks, the spreadsheets, and the programming can enhance both mathematical understanding and the CT skills. Reflecting on my experience with the NTU project, it became clear that the CT can enhance the mathematical learning when carefully aligned with the classroom goals. Okay, this is the outline of my presentation today. We will start from the what is the computational thinking and why is the CT important in the mathematics education, the innovative pedagogies supporting CT, tools and the technologies that support CT, the classroom applications, examples, and the case study, benefits of integrating CT in mathematics, challenges to consider, strategies for successful integration, glimpse into the future, and lastly, the final thought. Okay, before I start my speech, I want you to answer a quick poll. I have two questions. So I want you to answer the first one, the first question. Okay, wait, I will share the first question. Okay, can you see the questions? My first question is, have you heard about the CT in the context of mathematics? Okay, please answer it. I give you a few minutes, then we will move on to the second question.
Oke, silahkan Bapak Ibu scan barcode-nya dan you can answer the question from Dr. Chan.
Yeah, also share it in the chat box. If you can't scan the QR code, you can just click the link. Okay. I can see 13 words now. I give you another 1 minute because I'm not going to take too much time here. I just want to see the your answer.
Baik, silakan Bapak Ibu untuk mengakses link yang ada pada chat box ataukah men-scan barcode yang ada pada layar. You can scan the barcode or click the link in the chat box. Already 22 respond.
Yes,
Dr. Chan.
22.
Yeah.
Okay, so now I move to the second question. So have you ever applied the CT strategies while solving the mathematical problems? Yes or no?
Yeah. Then there is a second question. Please scan the barcode and maybe click the link. Same link. We're waiting your answer. Already 13 respond. Oke, silahkan mengakses barcode-nya atau mengklik link-nya Bapak dan Ibu sekalian. The second question already
Okay.
28,
Yes.
28 respond.
Okay, thank you for the moderator. Okay, let me present the answer here. Okay, the first question. Okay, the first one I can see is 60%, and the second one is 59, 60, also 60%, but it's for no. Okay, so most of you heard about the Sitti in the context of mathematics. So it's good to know you're already familiar with the Sitti in mathematics. So today we will look at how to use it more effectively in the teaching and learning. And the second one, we can see that some of you already apply for these Sitti strategies while solving the mathematical problems. Okay, so today we will learn how to use them more clearly and in the more helpful ways. Okay, thank you for your response. So now we'll proceed to the next part. Okay, now we will look at what is computational thinking. The idea of the CT can be traced back to the pioneering work of the Seymour Papert, who is in the 1980s, envisioned how the children could use the computer not just as tools for the computation, but as the instrument for learning, creating, and enhancing the creativity and innovation. He envisioned the technology not just as a tool for computation, but as a medium through which learners could actively construct the knowledge and express their ideas in the powerful ways. The essence of the CT is what we can do while interacting with the computers as extension of our mind to create and discover. In this view, the computer becomes a partner in the learning process, one that allows the learners to externalize the thoughts, test the hypothesis, and explore abstract ideas through the concrete models. Coined by the Genic Wing in 2006, the CT refers to the mental processes involved in formulating the problems and designing the solutions in ways that can be effectively carried out not only by the computers, but also by humans. In its core, the CT involves a systematic structured approach to the problem solving that draws on concepts and practices fundamental to the computer science, such as the decomposition, pattern recognition, abstraction, and algorithmic design. These four pillars represent the core problem-solving strategies that are fundamental to both the CT and the mathematics. Okay, let us look at the decomposition. It is breaking the problems into the manageable parts. We want to find the 1 plus 2 plus 3 plus etc. until plus 200. So we can paste the numbers from start and end. The first one is 1, and we plus with the last one, which is the 200, we will get 201. Then second and the second last is 2 plus 199. We will also get the same answer, which is 201. And the third last is 3 plus 198 is also 201. So we will sum out until 100 and 101. We will also get the same answer, which is 201. Okay, so we can form 100 such pairs because there are 200 numbers in total. So 100 pairs times 201, we will get 20,100. Okay, so we can breaking down the problems into the smaller part for us to solve the problem, especially for the complex problem. Okay, the second one is the pattern recognition. We will identifying the trends and the regularities. We will find also the sum of all the numbers between 1 and 200. Then we will see all the sums are the same, right? Then we will take 200 divided by 2. We will get 100 pairs. So 100 pairs times the 201, we will get 20,100. Okay, I will repeat the same question, which is find the sum of all the numbers between 1 and 200 for the abstraction. So the abstraction, we will focus on the important information only. So the first one is 1 plus 200, and the second one is 200 over 2. Okay, these two I will multiply. So 1 plus 200, which is the sum of each pair, we times with the 200 divided by 2, which is the number of pairs, then we will get 20,100. Okay, the fourth pillars is the algorithmic design, which is developing the step-by-step solution. Okay, so we will do it step by step. The step 1, we will do 1 plus 200, we will get 201. Step 2, we will take 200 divided by 2, which is 100. And step 3, we will multiply the 201 and 100, become 20,000 and 100. Okay, so we will use the same algorithm to solve the similar problem. For example, if I change the 200 to 1,000, which is highlighted in the red color, so you can see I already changed 200 to 1,000. So we're still using the same algorithm, which is 1 plus 1,000 for the step 1. We'll get 1,001. Step 2, we will take 1,000 divided by 2, we get 500. And step 3, we will multiply the 1,001 and the 500. We will get 500,000 and 500. Okay, so this is how we use the same algorithm to solve the similar problems. Okay, next, why is the CT important in the mathematics education? We can say that mathematics and the CT are deeply intertwined. It means that the mathematics and CT are closely interconnected. Okay, we have these elements, both involve the problem solving, and then both emphasize the logic and structure. Mathematics offer a natural setting for the algorithmic thinking and abstraction. And number 4 is the CT encourage the learners to think recursively, iteratively, and systematically. Okay, let us look at the example for both. Okay, we can say both involve the problem solving because they focus on the solving problems by breaking down into the manageable parts. For example, when we want to calculate the total cost of the items in the shopping chart, a student can list each item's price, add them sequentially, apply any discounts or taxes. Okay, this step-by-step approach mirrors how the algorithm work in the CT. Then the second one is both emphasize the logic and structure. The logical reasoning is fundamental in both mathematics and CT. For example, if we want to solve the equation based on the conditional statement, if the x is greater than 10, then the y is equals to the x times 2. Otherwise, it will become the y equals to the x plus 5. Okay, this conditional logic is similar to the decision making in the programming, reinforcing the structure thinking. Okay, the third one, mathematics offer a natural setting for the algorithmic thinking and abstraction. The mathematics problem often require recreating a series of steps, which is the algorithm, and focusing on the essential details, which is the abstraction. For example, if we want to find an average of a set of numbers, we will sum all the numbers, and then we divide by the count of the numbers. This algorithmic process coupled with using the variables like the n for the count demonstrates the abstraction. And number 4 is the CT encourage the learners to think recursively. So the recursive thinking is solving a problem by solving the smaller instances of the same problem. Iterative thinking is refining the solution through the repetition, and the systematic thinking is approaching the problems methodically. Okay, for example, if we want to calculate the factorial of the number n factorial, okay, so the recursive definition is both a mathematical concept and a programming function. Okay, we can say that the CT and the mathematics, they have the reciprocal relationship. We use the computation to enrich the mathematics learning through the technology and use the mathematical context to enrich the CT. Okay, let us look at what is the difference between the CT and our traditional mathematics instruction. The traditional mathematics focus on the correct answer, while the CT-infused mathematics focus on the processes and the strategies. The traditional instruction often rewards getting the right answer quickly, but the CT values the process, even if it leads to the multiple possible solution. Okay, the second one, the traditional maths involve the linear programming, problem solving. Meanwhile, the CT-infused mathematics involve the recursive and exploratory problem solving. So it means that the traditional methods often teach a single path solution, but the CT embraces the try and error testing and the refinement. Okay, the third one is the traditional maths involve the memorization of the algorithms. Meanwhile, for the CT-infused maths involve the creation and the evaluation of the algorithms. Okay, instead of just applying the formulas, the CT will ask the student to create or adapt them. Okay, the last one is the traditional maths is the teacher-directed, but the CT-infused maths is the student-centered and inquiry-based. The CT will foster the autonomy, the creativity, and the ownership of the learning. And this table shows that the CT does not replace our traditional maths, but it enhances it by making it more dynamic and engaging. Okay, following that, let us explore. Sorry, I share again. Okay, the next one, we will look at the innovative pedagogy supporting the CT. Okay, these pedagogies promote the active learning, which is essential for developing the CT skills. Okay, the first one is the problem-based learning. The students will tackle the real-life scenarios, such as modeling the population growth, which requires breaking down the problems, identifying the patterns, and creating the models. The second one is the inquiry-based learning. It encourages the curiosity and the independent exploration, leading to the deeper engagement with the mathematical ideas. The third one is the project-based learning. It combines the creativity with the technical skills, for example, using the Python to simulate the geometric transformations. And the fourth one is the cross-disciplinary approaches. It links the maths with other subjects, showing how the concepts apply across the domains. For example, physics simulations in the mathematics classroom. Okay, all these pedagogies emphasize on the 4 C's of the 21st century learning, which are the critical thinking, collaboration, creativity, and the communication. Okay, the next part that I would like to discuss is about the tools and the technology that support the CT. Let us look at the sketch or broadly. Is the visual programming platforms that introduce the logic and control flow without the syntax barriers. It is great for the young learners to understand sequences and the logic. Okay, let us watch this video. Okay, so from this video, we can see that we use a sketch, which is a visual programming tools. We can make the sprite, the cat, right? We can move the cat, move it up, down, left, and right by using the very simple coding blocks. And this introduced the students to the basic programming concepts, such as the sequencing, events, and the control. So this fundamental skill lay the groundwork for more advanced programming and the problem solving in the future. Besides that, we also have the Python. So it's a very powerful language for the high school and the university students, used for everything from the graphing to the machine learning. And the GeoGebra is the dynamic mathematics environment that blends the geometry, the algebra, and also the calculus interactively. And it is also for the older students exploring the complex models. Okay, for the spreadsheet, the Excel or the Google Sheet will allow for the pattern recognition, the function modeling, and the data analysis. It is also powerful for exploring the patterns, functions, and the modeling. Okay, then the robotics and the microcontrollers, for example, like the Microbit, the Arduino, is the hands-on devices that integrate the mathematics with the physical computing. Is ideal for measuring the angles, the distances, or the time intervals. They also integrate the measurement, geometry, and also algorithmic design. By using all these tools, we can transform the abstract mathematics into the interactive and tangible experience. Okay, now we will look at the classroom application examples and the case studies. Okay, this is the project that I already done in the Singapore secondary school, and we focus on the topic of the number patterns. Okay, from this study, the purpose of the study is to investigate the impact of the CT's activities in the topic of number patterns on the learning performance of the secondary school students in the Singapore. Okay, for the research design, a quasi-experimental non-equivalent groups design was used to compare the effects of the CT-infused mathematics lessons and the traditional instruction on the number pattern learning. For the experimental group, they received the CT-infused mathematics lesson. Meanwhile, the control group, they only received the traditional mathematics instruction. Regarding the respondents, 106 secondary 1 students, aged 13, from the Singapore school participate with the 70 in the experimental group and 36 in the control group. Okay, concerning the instrument, the pre-test and the post-test were developed based on the number patterns topic, including the recognizing patterns, finding the next terms, and the deriving the general formulas. And this pre-test and post-test were validated using the rush analysis for the reliability and the unidimensionality. We ensure that the item fit within the acceptable range. For example, the outfit mean square is 0.5 to 1.5. Okay, for data collection, we conduct this research over 5 days during the regular mathematics lessons, including the pre-testing, intervention, the CT activities for the experimental group, and the post-testing. Okay, for the experimental group, they engage in the CT-infused activities. They also involved in the unplugged activity and the plug activity. So the unplugged activities, later I will show you the example, the worksheets that we use. And the plug activities, we use the spreadsheet, which is a spreadsheet-based task. And they do the computer work in pairs. Okay, meanwhile, for the control group, they taught using the traditional methods without the CT integration. Okay, for data analysis, the rush parser credit models were used to analyze the test results, along with the person fit statistic, the right max, and the logic value comparison. And the software used is the WinStep version 3.73. Okay, let us look at the spreadsheet that we designed. for the number patterns. So this is the plug M+C activities using the spreadsheet. So we also use the 4 pillars, which are the pattern recognition. Okay, the student will draw a scatter plot to represent the data to review the patterns of the data. Okay, for decomposition, the student guided to do the decomposition by breaking down the problem into the smaller problems. For example, the problem 1 is what is the starting number, where to key in, and the second problem is how do I use the recursion method to generate the number pattern. Okay, then for the algorithmic design, the student will utilize the spreadsheet to perform the recursion method and attain the final product as shown in this figure. And lastly, the abstraction, the student will ask to generate the general formula using the abstraction method. Okay, then these are the photos during the plug M+C activities using a spreadsheet. The students are work in pairs. Okay, then we also do the unplug M+C activities. It means that we don't involve any computer for the unplug activities. We also use the 4 pillars, the pattern recognition. We find what is the difference between each term in the sequence, and the decomposition, the student need to break down the numbers in the table. And the algorithmic design, the student are asked, do they notice about the highlighted numbers in the last column, and what is the relationship between the position number and the highlighted number. And lastly, the abstraction is what is the general formula that we can use to find any number in the sequence that you see in the previous page. Okay, then we also have the pre-test and the post-test that I mentioned just now. So some of the example are find the missing terms and then write down the next 2 terms, or we ask the student to predict the figure number in the sequence contains 136 bricks and justify their answer. Okay, then these are the results of the experimental design, experimental study on the number sequences. We can see from this table, the experimental group had a 4.53% higher than the control group. Okay, if we look at the percent measure in the pre-test and the post-test. And the improvement of the experimental group was better than the control group. Okay, this is a right map using we use the Rush model. So for this, we can see the performance of the experimental group was improved significantly. For example, like A19, we see before that, the logic were below the mean of the item logic. But after the CT-infused intervention, the performance improved significantly and moved to the above the mean item logic in the post-test. This is a pre-test, this is a post-test result. Okay, so we also have other students that improve very significantly. And the drastic improvement is the A53 and A59. Okay, these two they increase almost 3 times until the maximum logic. Okay, so I can make a conclusion that the study found that overall performance of the students that engaged in the CT's activities was similar to the control group, but some individual students in the experimental group, they show very significant improvement, but no extreme improvement were observed in the control group. And this suggests that the CT-infused instruction has the potential to enhance the learning outcomes for certain students. Okay, because we have the limitation of this study is the short intervention time, only 3 hours and 30 minutes. So also the limited familiarity with the spreadsheet tools, so which may negatively affected the effectiveness of the CT interaction. Okay, the future research should focus on the longer interventions, better scaffolding for the computational tools, and developing assessment that measures both CT and the mathematical understanding. Okay, sorry, I think my slide is, I need to share again. Okay, now we look at the real case for in the Malaysian context. One of the initiative of the government, they promote the city in the Malaysia. We have this school coders program, which is the Malaysian initiative aimed at promoting the STEM education and building the inclusive communities by teaching coding skills to the students. Launched in the collaboration with the tech industrial partners, this program focuses on empowering the students from diverse backgrounds, including those from the rural, urban, and the indigenous communities, as well as the students with the disabilities. This program is implemented in schools across Malaysia, targeting primary and secondary level students and educators, and is inclusive students of all the abilities. And this initiative utilizes a combination of the curriculum-based coding education, hands-on activities, and the practical projects to engage the students in the STEM learning. Okay, let us look at focus on these benefits of integrating the CT in mathematics. Each benefit reflects a core outcome of the CT integrated maths education. The first one is promote the deep understanding of concept. The CT forces the students to think about why something works, not just how. Okay, the second one is it encourages the logical reasoning. The coding and the algorithm design require the precise logic. And the integrating CT in maths also enhances the creativity and innovation. The student will design their own solutions and models. And it also builds the resilience through the iterative problem solving, such as the debugging, refining algorithms, and testing solutions that encourage the perseverance, adaptability, and growth mindset while facing the challenges. And last one is prepares the student for digital futures. The exposure to the coding and the tools prepares the student for the future tech-driven jobs. Together, these benefits ensure the students are not just learning mathematics, they are learning to think like mathematicians and the innovator. Okay, while the CT offers the numerous benefits, its implementation faces several challenges that need to be addressed. So for example, like the first one is teacher preparedness. Many educators, they lack of the experience with the CT or coding, so they need the support to teach the CT confidently. The second one is the curriculum overload. We adding the new content without removing the old material can overwhelm the teachers and the students. And the third one is the assessment gaps. the current assessment may not capture the CT skills effectively. And the last one is the access and equity. Not all the schools, they have the equal access to the technology or training. Okay, all these challenges require the systematic solutions, including the professional development, the policy reform, and the equitable resource distribution. Okay, let's take a closer look at the strategies for successful integration. So these strategies provide a practical roadmap for the educators. The first one is start small, one lesson at a time. Like us, just now I show the example, which is the number pattern. We can focus only one lesson. Begin with a very simple CT enhanced lessons to build our confidence. And then the second one, we can collaborate and work with the ICT or science teachers. We work with the colleagues to co-design the interdisciplinary projects. And the third one, we can use the open source tools and the resources, such as the Sketch, the Python, and GeoGebra to reduce the costs. And the fourth one is attend the workshops or the online courses. We can take advantage of the workshops or online courses to learn the CT skill for the professional development. And last one, we encourage the student-led learning and curiosity. We allow the student to choose the projects, ask questions, and explore the independently. These strategies ensure the CT adoption is manageable, sustainable, and inclusive. Okay, let's continue with a glimpse into the future. In the future, we can imagine the personalized learning powered by AI. So the adaptive system that tailor the instruction to the individual needs. And we can also imagine that the real-time simulation in the mathematics classroom, the interactive environments where the student can manipulate the variables instantly, and collaborative global mathematics projects. The students worldwide work together on the shared mathematics challenges. And also, we can imagine the data-driven decision-making by the students. We're empowering the students to interpret the data and make the informed decisions. So CT is a pathway to these futures. And it makes the student not just the consumers of the knowledge, but the creators of the solutions. We can say that the CT opens the door to a future-ready, digitally literate generation of the problem solvers. Okay, I would like to conclude my speech with this quote. Mathematics is not just not about the numbers, equations, computations, or algorithms. It is about understanding, from the William Paul Thurston. This quote reminds us that the true mathematical understanding goes beyond the symbols and the calculations. It is about the grasping underlying principles and the connections. Okay, so the key message of my speech is that CT is a bridge to the mathematical understanding. By integrating the CT into the mathematics education, we can make learning more meaningful, engaging, and future-ready. CT helps the students see the why behind the how, and transforming the maths from a subject to be endured into one to be explored and enjoyed. Okay, so these are my publication on the CT. Okay, and with that, I wrap up my speech, and thank you for your time and attention.
Okay, thank you very much for your insightful presentation, Dr. Chan. Okay. Well, we now move into our Q&A session. Please feel free to raise your hand and drop your question in the chat box. And I will read. There is a question in the chat box. Okay, wait. There is three question, and I think it is for Dr. Chan. I will read the question. The first question is, during the implementation of Sitti-infused learning, did you observe any distinctive mental representation among students, such as visualization, pattern grouping, or specific algorithmic strategies?
Okay.
Okay. Maybe, yeah. Just,
Okay, thank you, the moderator, for the question. Okay, as I said just now, because we conduct the research on the number patterns, so we can see the drastic improvement of the students, especially in the experimental group. Okay, so when they solve the problems also, they will use a very different way if compared to the control group, because the experimental group, they will involve the CT and they use the spreadsheet, right? So their thinking is we can say that it's different from the control group, which is using the traditional mathematics instruction. That's my answer. Am I answer the question?
Okay, thank you. There is the second question from the same person, from Bapak Andi Mulawakan. And the second question is, my research focus on the use of augmented reality, AR, to facilitate student understanding of number pattern. In your opinion, how does AR compare to worksheet or spreadsheet-based approach, such as those used in your study, in terms of developing students' computational thinking or mathematical reasoning strategies? Please, Dr. Chan.
Okay. Thank you, moderator, for telling me these questions. So I will also see in the chat box. So
Yes.
it's a very interesting research because you are using the AR, because my research is only using the spreadsheet. So I think the difference too, they will have the different outcomes or the result if you want to developing the students' computational thinking. So how does the AR compare to the worksheet or the spreadsheet approaches? Okay, the spreadsheet-based approaches, we focus on the 4 pillars. So normally the 4 pillars will integrate into the our instruction. Okay, so I can say that maybe you can try to use these 4 pillars also for your AR method to develop the computational thinking. This is my suggestion.
Okay, thank you, Dr. Chan. This is the answer from Dr. Chan, Pak Andi Melawakan. And then we go to the third question from Bapak Muhammad Muzaini. He questioned that how can Sitti, computational thinking, change the paradigm of mathematics learning in higher education, especially in shaping students' way of thinking about problem solving? Okay, maybe just answer, Dr. Chan.
Okay, thank you for the questions. Okay, so just now I also say that computational thinking is different from the traditional maths instruction. So in shaping their way of thinking about the problem solving is like the traditional maths is only involve the linear problem solving, but the Sitti-infused maths is the recursive and the exploratory problem solving. Okay, which is different if we use the traditional method and the Sitti-infused maths. Okay, if we want to say that how it shaped the thinking about the problem solving is that the traditional methods only teach the single path solutions, But the Sitti, we will use the try and error, and then the testings, refinement. So it's different way like in shaping the students' way of thinking about the problem solving. Okay, so that's my answer. Thank you.
Thank you, thank you. Thank you, Dr. Chan. So maybe a little question from me. I think your presentation show how computational thinking helps students approach math more logically and creatively. You also gave example of tools like spreadsheet, like Stretch, that make learning more hands-on. But for many teachers, especially those new to the city, getting started can feel overwhelming to teacher. So my question is, what is one simple way to teacher can begin introducing Sitti in a regular math class without needing advanced technology or programming skill, maybe?
Okay, thank you, Doctor, for the questions. For the start, actually, I suggest you can use apps like the Lightboat. Lightboat is one of the very simple games for the students. It's like a game, and the student will enjoy it very well. And the student will not know this is a coding or what. So this tool is maybe I can share it. So it's a very good game for the starting. If the newbies we can use this, and it's also an app for you to download. Okay, let me share. You can just download from the this one. You will work forward or turn 90 degrees or the left. So in the apps also we have in the Google Store, you can just download and play this game. So it's very simple coding, or you can say exposure to the students about this. So actually this game also I know it during my post doctoral studies. They also expose this to the students in the early age, especially like the kindergarten or the primary school. Okay, they will start using this. So it's a quite good apps for all. Okay.
Okay, thank you very much.
Okay.
This is so interesting. Okay, there is another question. Maybe just raise your hand, ladies and gentlemen. If there is no question anymore, maybe we approach to the end of today's session. Okay, let me summarize the key point from our two speakers.
Izin Ibu, boleh dicek dulu chat box-nya, kayaknya ada satu pertanyaan ini.
Oke, sorry.
Izin, boleh bertanya langsung, Bu?
Oke, silahkan. Oke, saya baca dulu ya yang satu ini.
Okay.
From Ibu Fadilah binti Ismail. Okay, Dr. Chan, how does the use of computational thinking tools like spreadsheet and coding platform support the development of logical reasoning and creativity in mathematics learning? Please, Dr. Chan, you can answer the question.
Okay, the use of the tools is like you can use it as a medium. The student can actively construct the knowledge and express their ideas in the very powerful ways. And the use of the tools also like a partner in the learning process. We allow the students to test the hypotheses, and then they can explore the abstract ideas through the concrete models. Okay, so it can support the logical reasoning and also creativity in the mathematics learning. Okay, that's my answer. Thank you.
Okay, thank you. Apa ada Bapak dan Ibu yang ingin bertanya lagi? Mungkin langsung ya, langsung bertanya. Open hand, silahkan.
Bu Irna. Saya Bu
Silakan
Irna.
Ibu Andi
Iya.
Husniati, silahkan Ibu.
Yes. Okay.
Please.
I'm sorry I don't open my camera. Good evening, Mr. Dr. Chang. I have a question because my research about disability student, deafness student. I am interested about your computational thinking, but I'm confused how to use of computational thinking in disability class. Thank you.
Sorry, what class is it?
Disability class. About deafness student, my research about deafness student, how to about their understanding in mathematics. So I think this computational thinking we can use in this class, disability class.
Okay. If you want to apply, thank you for the questions. If you want to apply in the classes, we can use some of the tools such as GeoGebra, or the Python, and others technological tools in the classroom. So we can design according to the 4 pillars. Just now I already mentioned, how do we going to spread the decompose the problems into the smaller parts, and then use the abstraction. We ask the student to generate the formula, and then we also have the algorithm, how to step by step solve the problems, and also the identifying the patterns. So when you design the worksheets or any task for the students, you can follow the 4 pillars, and then using the technological tools. As I suggest just now, we have a few tools, right? So in any classroom, not just mathematics, I think the science and also computer science, any classes we can just apply it.
Is it free, Dr. Chan, or you need to subscribe?
GeoGebra is a free one, and then the Python and also the Sketch broadly also. All these are the free tools for us to use. Okay, am I answer your question?
Okay.
Okay, Ibu Andi Husniati, ya.
Okay. Thank you, Dr.
Okay, thank you very much for your question, and thank you, Dr. Chan, for the answer the question. Okay, ada lagi? Mungkin ada lagi yang ingin bertanya, silahkan langsung raise your hand and to. Oke, mungkin tidak ada lagi ya. Tidak ada lagi pertanyaan. Kita sudah membacakan semua pertanyaannya. We already read all the question. And as we approach in the end of today's session, I will try to summarize the key point from our 2 speakers. First, from Dr. Sitti Fithriani Saleh, in the title of Integrating Cultural Context and Technology in Mathematical Education. Dr. Sitti emphasized that math and culture are interconnected. Using local culture in math lesson makes learning more relevant and engaging. She shared an example of a Papua-based digital math ebook to support student understanding despite the challenges integrating culture and technology support inclusive meaningful education aligned with SDGs. And the summary of our second speaker, Dr. Chan Shiau Wei, in the title, and changing mathematical understanding through computational thinking. And Dr. Chan introduced about Sitti, computational thinking, as a key method to change math learning through decomposition, pattern recognition, then abstraction, and algorithm design. She present a case studies showing how Sitti infused lesson improve the student outcomes, support by tools like Stretch, Python, and spreadsheet. And the Sitti bridge math with digital literacy and prepare students for future problem solving. Okay, that is the summary. And this session has provided us with rich insight and how innovation in education must remain both inclusive and purposeful. Okay, well, before we close, we kindly invite all participants to turn on your camera. This is for a group photo as a part of our official documentation. Okay, please silahkan Bapak dan Ibu sekalian untuk open kamera karena kita akan mengambil dokumentasi sebelum kita officially close. Oke, mungkin kita akan dipandu dengan Kakak Rijal.
Ya, baik Bapak Ibu, so let's start with the first screen. So please turn on your camera and smile. Okay, 1, 2, 3. Okay, next slide. Okay. 1, 2, 3. Okay, next slide. 1, 2, 3. Okay. Next slide. One, two, three. Okay. Last slide. 1, 2. Smile. Yeah. Thank you.
Thank you very much, Kakak Rijal. And before we officially close this session, we invite Kaprodi, Ibu Kaprodi untuk closing remark maybe, and Ibu Fadilah to get the closing remark for our session. Silakan. Silakan, Ibu Dr. Sitti dulu. Ya.
Oh, thank you very much, Dr. Irna. Well, I really appreciate our international guest lecture this afternoon, and we hope we can collaborate in another activity, for example, joint research collaboration with Dr. Chan and Professor Fadila. We have some lecturers here who is interested in number pattern and city. So we can collaborate and make a community engagement also. I hope we can make a collaboration for the future. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi
Waalaikumsalam.
wabarakatuh.
Okay, maybe Dr. Fadila, please.
Alright,
The
2.5
closing
hour, I
remark.
think our program this lecture. Thanks for the sharing session, and Dr. Sitti, thank you very much. I think this is a good collaboration between our two universities. So today is on the innovation on the mathematics. So inshallah, I think for next collaboration, we also do have a lot of expertise in different area. Maybe we can collaborate in terms of that, or we can collaborate in terms of the student activity and so on. We already discussed with Burida. So I hope this is not the end. They have a lot of collaboration that we need to engage together. Of course, to strengthen our university, to strengthen our expertise between both parties. So on behalf of UTHM, FBDB, I'm very thank you so much to Ibu Rida to organize this program, international guest lecture. Thank you so much, Dr. Chan, for today. And then I hope that they have a lot of things that both party benefit together, and for the students, those who enjoy get benefit, and I think bring the new inspire of idea and knowledge. So hopefully that this is the starter, and inshallah we're going to continue. We are very open to get the new collaborations, to get the new engagement together. So thank you very much. Pass to the moderator.
Thank you very much for all speaker, to Dr. Fadila, Dr. Sitti, Fithriani, and on behalf of the organizing committee, we're very thankful for our speaker and everyone who participated. We hope to see you again in the future academic collaboration. Billahi fisabilil haq, fastabiqul khairat. Wassalamualaikum warahmatullahi wabarakatuh. And goodbye.
Waalaikumsalam
Waalaikumsalam
warahmatullahi
warahmatullahi
wabarakatuh.
wabarakatuh.